Hello, Mr. Eric, Mr. Ryan, are you right?
Yeah.
Okay, so what's Sudoku?
It's like a 9 by 9 square.
And
And it's filled with numbers, not all numbers, and there's 9 squares with 9 squares inside and 9 columns each.
okay, like that, right? So each one is 9 times 9, right? And then what are the rules for that?
Every square and row and column.
So you try to fill the numbers with 1 to 9, right?
Yeah, and also the rows and columns to 1 to 9.
Okay.
And they all have to equal. And they all have to equal.
So let's say 1 is here, I can't put 1 there.
And then also 1 there, right? Yeah?
Yeah, so like I
And they all have to equal up to
I
9.
see.
yeah.
And they all have to equal up to 9.
What do you mean equal up to 9?
Well, I'm not sure if that's the number actually.
So yeah, to sum up, yeah, we put the numbers 1 to 9.
I'm actually not sure if you.
Okay.
It has to equal to 9.
We put the numbers 1 to 9 in each box, little box, there are 9 of them. And the numbers, each number can only appear once in each row, each column, and obviously in its own cell, okay? When we talk about this Sudoku, we talk about, how to complete, how to solve it with some numbers in there, but some numbers we need to determine, right? So we use the backtracking. So how do we backtracking? I show you. It's very easy. Depth of search. Yeah, basically depth of search. So if this number is missing, yeah, we try to determine, right? And then we can try, we can try 1, 2, 3, 4 up to 9. And if it violates the existing rule, we just try the next one. If it doesn't violate, for example, if I can put a 4 here, right? So I move to the next one. Move to the next empty cell and then keep trying. Depth of search, backtracking. The idea is very simple. Depth of search, yeah? Go deeper as you can, right? So if we can put the number 4, then we move to the next one. If we can't put the number 4 here, we try number 5. If we running out of digit up to 9, then we go back to the previous solution, previous empty cell. For example, the previous one is 3, and then we increment this to 4, right? This is backtracking to solve this Sudoku problem. Okay, so today's question, similar like yesterday, we designed a maze. So the question is, we want to design an algorithm that design Sudoku.
Does it have to be so when you say design a Sudoku, so we want to return a fully solved Sudoku?
That's a very good question. So I just said design Sudoku. And that's it. You need to ask a lot of questions before we actually go into the details, okay? So these are questions to clarify, right, the requirement, okay? So you're saying, does it have to be fully solvable, right?
Do we have to return a solved Sudoku?
No. You play the Sudoku game, right? All numbers are filled in. We don't play, right? It's already there. So the question is that design Sudoku that returns partially, right? So it can be played. We can play on it, right? And that's a very good question. So it's partially, right? It has to be partially filled or partially completed. The second one is, any more questions? Any more questions? We can ask. Any more questions? When you play the Sudoku,
Is it solvable?
it's solvable. That's a good question. Yeah, obviously it has to be solvable. If it's not solvable, the worst case, I can just put random numbers in there and you can find a solution, right? For example, I return a Sudoku and with 2 1s here. No matter what the rest, it's not solvable because 1 and 1 is here, right? Okay, solvable. It has to be solvable. And any more questions?
It has to have 9 by 9 squares.
Obviously, Sudoku is 9 by 9. Okay. So when you play the game, you can choose something to play. You can set the level of. What is that? When you play the game, usually you can set the level of what? Level of what?
Sudoku.
Easy.
Yeah. What do you?
medium,
Yeah. What does it call?
Hard master.
Yeah.
hard.
Difficulty, right? The level of difficulties. Yeah. Alright. That could be one of that level of difficulty. And another one is how many solutions. Okay, because some Sudoku could have many solutions, right? If you're saying, okay, there's only one unique solution. Yeah, okay, maybe one unique solution, right? So there's only one way, right? Obviously, if you are given empty Sudoku, there are how many? These two numbers, right? 6.679 times 10 to the power of 21. So 10, this number followed by 21 zero. This is a huge number. So this is the number of total Sudoku valid states. Right? But if we remove the duplication like some states may be the same. If you transform, if you rotate it, mirror it, right? And it brings down the number to 5.4 times 10 to the power of 9 valid solvable states. Okay? Yeah, make sense? Okay. So we're saying that if we return an empty cell, and then obviously this is not unique. Okay. Okay, so these are the requirements, right? We want to return a partially filled state, and it has to be solvable. If it's not solvable, there's no point, right? And then the level of difficulty, this is optional. We need to consider the level of difficulty. Usually, okay, so how do you know if it's easy Sudoku? How do you know it's hard? By looking at what? So
The numbers.
the number. How? I mean, how do we know it's easy? How do we know it's difficult Sudoku? By giving you two Sudoku, how do you tell which one is easy to solve?
The one that's easy is the one which is mostly filled.
That's right, yes, because more numbers, more clues, right? So it's easy to solve. Less number, you have to try, right? Am I right? Yeah. Then it's more difficult to solve.
That's exactly what I said about the numbers.
The number of numbers, yes, I understand.
The
Good job.
number of numbers.
Okay, so how can we design that?
Mattress.
So I think
Would
we
you just write numbers?
Yeah, but how, I mean,
I think we have to get a Sudoku and fill all of it and then delete a load of them.
very good. So first of all, we need to find a completed Sudoku, right? Sudoku.
And then remove numbers.
And then remove the numbers. Remove a digit at once, right? Step 2. Right? Remove a digit. That will return a valid solvable state, right? These two steps satisfy this one and this one. How about level of difficulties?
Remove
More.
amount of.
Yeah, okay, so we can simply
Remove a certain amount.
Yeah. So we can simply repeat the step 2 to make it this one. But how about this one? How many solutions? If we want to make sure it's only one, how do we make sure if it's only one?
That's basically the first step.
We are finding a complete. Let's start, right? Complete, and then it has to be random, right?
Yeah.
We don't want to. We don't want to return the same every time. It has to be random. Okay, we come back to the step 1 later. Remove a digit, right? And then we need to check if it is solvable, right? And obviously it's solvable. And check if it's solvable and only one solution, right? If it is solvable and if we have removed a certain number of digits, right? This could be a parameter. Like if we want to remove n digit. So for example, if we remove the one digit, if we remove the 1 to 10 digit, then we say it's easy, okay? If we remove 10 to 20 digit, 11 to 20 digit, we say medium, okay? For example, if we remove 21 to upwards, it will be hard, okay? To 30, okay? This is just example of configuration of the game. If we remove the up to 10 digit, it's easy, okay? Remove one digit at a time. If we go back to check if the Sudoku can be solvable and contains only one solution, right? We can use the backtracking, right? To count how many solutions. If we already remove n digit, then that's it, right? If not, okay, what happened? If the digit we remove these too many solutions, then we have to put a digit back, right? Because if we remove the digit, for example, if we remove this 9, and then we found out there are 2 solutions, right? Then we have to put the number 9 back, right? Make sense? Okay, so the first one, find the completed random Sudoku. How do we find? We can just simply do the backtracking, alright? But with some randomness. So we try, for example, we can try, instead of trying from 1 to 9, we can randomly select the number. We can shuffle the selections, right? The next number we could shuffle. So for example, the next one is empty set, right? Empty set. Then we can randomly pick an integer from 1 to 9 instead of trying from 1, 2, 3 up to 9, right? Previously, when we do the backtracking to find a solution, we always try from 1, right? So, but we want to return some randomness, then we can choose the random integer there. And once we complete, find a Sudoku state, we remove a digit. And we check if this Sudoku is solvable and only one solution, right? Only one solution. Then if it is, we keep removing until n digit, right? Make sense? Yes? Okay. So what have you learned today?
We learned about how to generate an algorithm to make a Sudoku.
Yeah, Sudoku. Okay. I mean, obviously, the brute force way is I just randomly generate number. I put the numbers there and I randomly take it out and I check if this Sudoku is solvable. But that's going to take more time, am I right? Yeah, because when you randomly put the numbers in, you cannot guarantee that
This
it's
one
solved.
this one not solvable.
Yeah, that's what I meant, right?
Because the only number could go here is 4 and there's already 4.
Yeah, I know. This way is a very inefficient. It's not practically useful, right? When you randomly generate the numbers, right? So when you randomly generate the numbers, it could be anything, and it could already be unsolvable. And no matter what numbers you taken out, it's still unsolvable. And you have to check. You can do this. Repeat. You generate a random Sudoku. Check if it's solvable. If it's solvable, then break. Otherwise, repeat. But this is not very good. Okay, that's what I said. One better way here is that we use the backtracking algorithm to find completed Sudoku with some random. Yeah, we want this Sudoku to be random, and after that we remove a digit at a time. Alright, we could remove any random digit at a time, and if after we do removing the random digit, if it has more than one solution, we put it back. We put a digit back. We try the next one, right? If it's only one solution, then we can keep removing it until n digit. And this is n digit. This is the level of difficulty. Okay? Does it make sense?
Yeah.
Okay, that's it for today. Bye bye.
Bye.
Bye.